In 1997, a fire broke out on the Mir space station, the predecessor of the International Space Station. The culprit was the spacecraft's onboard oxygen generator, which burned solid lithium perchlorate canisters to create a breathable atmosphere. Material from a latex glove, probably left inside the generator during its assembly, ignited when the machine was activated, spawning a fire that burned for about 14 minutes before it could be fully extinguished. Although none of the crew got hurt, the accident underscored the difficulty and safety risks of providing astronauts with a continuous supply of oxygen throughout their time in orbit. Similar to onboard water filtration systems, the contraptions that produce this life-saving supply have evolved significantly since the space race lifted off in the 1960s. For more fascinating stories about space exploration, subscribe to our channel and join us on this incredible journey beyond Earth. The Apollo program, including the 1969 mission that first landed humans on the Moon, used an Environmental Control Unit, or ECU, to maintain an atmosphere of pure oxygen in the command modules. The ECU was fitted with lithium hydroxide and charcoal canisters to filter carbon dioxide from astronauts' breath and absorb odors. It also generated water and maintained the cabin temperature, allowing up to 3 astronauts to survive in space for 14 days. Space Station Mir, which launched in 1986, was designed for longer space missions and generated oxygen through chemistry. A generator ignited lithium perchlorate canisters about the size of large spray cans, which released oxygen as they burned. One of these oxygen candles provided enough breathable atmosphere for one crew member for 1 day, but the system showed its vulnerability during the latex glove incident. Following that accident, aerospace engineers moved away from using chemical reactions to generate oxygen in space. The ISS replaced Mir in the early 2000s and is equipped with a safer ECU based on electrolysis, which uses an electric generator to split water molecules through a proton exchange membrane into oxygen and hydrogen. While the oxygen produced via this process is released into the atmosphere, the hydrogen is combined with carbon dioxide exhaled by the crew to produce drinking water and methane. The latter is currently vented off the station, but could one day prove useful for onboard biomanufacturing processes. The ISS also carries the Mir model of oxygen generation as a backup. Providing astronauts with oxygen when they're inside a spacecraft is one thing. Doing so when they leave the spacecraft to go on spacewalks, to test equipment, conduct experiments, or carry out external repairs, is quite another. A modern spacesuit designed for spacewalks, also known as an extravehicular mobility unit, or EMU, is equipped with a backpack containing multiple life support systems. Among other functions, it delivers oxygen to the astronaut's helmet while filtering out carbon dioxide. The suit also protects their body from the potentially life-threatening forces of the vacuum into which they venture. Even before getting in an EMU, astronauts spend several hours breathing pure oxygen inside a pressurized airlock to minimize their chances of getting the bends. According to retired astronaut Mike Mullane, a command module maintains atmospheric pressure of 14.7 pounds per square inch, much like Earth at sea level, but the pressure in a spacesuit is only 5 psi. Astronauts must pre-breathe pure oxygen to remove nitrogen from their bodies and prevent the formation of gas bubbles in their blood, the cause of the bends, before going on a spacewalk. Otherwise, the excess nitrogen bubbles could block blood vessels and cause tissue damage, leading to joint pain, headaches, muscle weakness, numbness, fatigue, and confusion, among other things. The importance of spacesuits is perhaps best illustrated by what would happen without them. The astronauts would immediately pass out from oxygen deprivation, while the forces of the vacuum would cause their blood and bodily fluids, which evolved in accordance with Earth's atmospheric conditions, to freeze, boil, and rupture. The conditions of space turn an action as simple as breathing into a complicated, potentially deadly ordeal. Fortunately, that's nothing science can't handle. If you enjoyed this video and want to see more fascinating content about space and science, make sure to subscribe to our channel, like this video, and hit the notification bell so you never miss an update. Thank you for watching.